All right. This one was, yeah, electric dryer getting an airflow error. These are customer side error codes, so you don't have to go into service mode to see these. It just shows up on the UI.
Wow, so this actually
AF.
measures air. This is a dryer that actually measures airflow, Sam?
Yeah, they've got an anemometer just built into the circuitry.
And somehow
Yeah.
it's hooked up to the computer so the computer can directly read the anemometer.
Yeah.
Okay,
No, it's
guys, I'm being
crazy.
totally sarcastic. That's exactly not what they're doing. You're going to see how they're doing it. So they call it that they're doing. It's kind of like what the game LG plays with their flow sense. They're not actually measuring airflow. They're using some other parameter as a proxy to guess about airflow. In this case, they're using, well, I'll let Sam get to that. In the LG case, they're using the open and closing of the high limit. So it's
Yeah.
kind of kludgy, and I don't know how well it works, but anyway, that's how they market it. So this is marketing stuff.
However, this is another case, kind of like the previous one. I guess it's sort of a theme today of them hiding the information you actually need. Because right here on the customer side code, the description they gave is just, oh, it's got to be either something obstructing the airflow. It's got to be clogged vent or clogged lint screen. And even when you go into service mode, which should be your first step on any service call, go into service mode, pull up error codes.
Yeah, if you're dealing with
No reason not to.
a computerized appliance, first thing you want to do is talk to that computer just to have it tell you stuff, whatever it's going to tell you.
You see down here at the bottom, restricted airflow. There's a code for it. Doesn't mention anything about the thermistors. Again, and this is the tech side error code where it should have more information. But no, it just says, oh, probably a clogged lint screen or clogged vent.
Wouldn't
Um,
this be a good place to tell you what functionally causes, what component is primarily responsible for throwing that error code? That'd be a great place to include that information, but no.
and so our tech, the tech that I got this topic from at Appliantology, he checked the airflow himself, said that to him it felt good. Okay, he didn't pull out an anemometer or something, but we'll take his word for it that it's a good airflow coming out of the vent. So you have to dig through and you have to go through the dummy directions, which is where I am here. Not only to find your thermistor resistance tables, but that is the only place in any of the documentation where, with this paragraph, they call out how the airflow sensing works. The ACU monitors the inlet temperature using the inlet thermistor. The inlet thermistor, along with the outlet thermistor, is used to detect airflow and assists in calculating load size.
Okay, what they just gave us there, that's insight into the algorithm of the computer, how it works. That you cannot get this information by reading the schematic. There's no way to know that. This is software that's programmed into the operating system of the computer that runs the whole appliance. So they have to tell you stuff like that could affect your troubleshooting, which they are right here. By the way, this illustrates two good reasons to just scan the dummy directions. We don't scan them for procedures and look and what do I check now? We're looking for two things. Did they bury specs in here? Oh, yes, they did. They buried the
Yep.
outlet thermistor spec. And do they have tidbits on the algorithm that may affect my troubleshooting? Yes, they did. So that's what they did in this case. How did I know to do that? Because it was like, well, there's no place else to look. And I knew what I was looking for.
Yeah, if there are specs you need, like a thermistor table that are just missing from where you think they should be, that's your cue to just start pouring through all the information you have
Right.
until you find them. Because
And
they're there somewhere, and if they're not, then that's kind of where your troubleshooting
so
has
what
to
you
stop.
do, I mean, it's not like the old days where you got a paper manual, right? And you got to thumb through and read each one. It's a PDF. Pull it up in a PDF reader, use the find function in your PDF reader and search for keywords like thermistor.
Yeah, just search for thermistor.
And so you're not, it'll just take you minutes to get right to the page that oh, look, this one has it out of the 12 possible pages with the word thermistor on it. And then, oh, you just thumb through those find results real quick and there you go.
Yep. Yep. And they got the inlet thermistor down here. Yeah, outlet up here, inlet down here. So you've got both of the resistance tables that you need buried in these dummy directions here.
Yeah, and so one of the questions he asked in the topic was, how does it sense airflow? And the answer to that was on the purple circled thing on the other page, Sam.
Yep.
That's the answer right there. And so which tells you then what action does that inform you that you should be your next step? What are you thinking when you see something like that? And you know I'm getting an airflow error, and the airflow is determined by some secret sauce between the inlet thermistor and the outlet thermistor that's coded in. What's my next step?
Check the thermistors.
Yeah,
Absolutely.
absolutely. You got it.
Two of them.
Right
And you got
on.
them right here.
So an
Outlet,
easy test,
inlet.
they give you specs, but when you get to the home, the dryer should not be running, should not have been running. You know, if it's broken, they're not using it supposedly. That's why they're calling you. So it's been sitting there at room temperature. So right away, you got two good temperatures at which to take your thermistor resistances. And Sam, if you go back to that table, and let's just say that the room is at,
70 degrees.
let's say 70 degrees because it's right there. Then you know you can check your outlet thermistor right there, and you're looking for a resistance in that range to see if that thermistor is in spec, at least at that data point, at that temperature.
Yep.
And you can do the same with the inlet thermistor,
And remember, it's calling out K ohms here. So you're not looking for 11.5 ohms. You're looking for 11.5 thousand ohms.
1,000 ohms. Yeah. So they're giving you the specs, and you can start off with a quick check. Oh, AF, and it's using the thermistors to lie about airflow. Then okay, fine. I'm going to check the thermistor specs and make sure they're not lying to the board.
Yep. So you got your spec. You just got your outlet thermistor right here. It's funny, they give a resistance spec for it.
Yeah, at roughly this must be at roughly room temp.
Roughly room temp, yeah. That
So
would be what, yeah.
easy test, and you don't have to tear apart the dryer to get to these thermistors. Where am I going to test the thermistors?
On the main board.
Right.
Absolutely.
Yeah, again, using the schematic as your roadmap, you'll just follow the lines back to the board where it connects. Dead circuit, ohms measurements are made on a dead circuit. I always like to isolate the thing I'm testing from the rest of it so I don't get possibility of weird readings back through the board, which could happen because they're not
Hmm.
showing me what's going on the board. So I just unplug that, what is it, P14 connector there,
Yep,
and
P14.
check pins, what, 3 to 4? What's under
3,
your other
4.
purple?
Yep.
Oh,
3
3
to
to 6.
6.
Yeah. And then just back probe that harness connector when it's disconnected at pins 3 and 6. And you're looking for about 10K at room temp.
Then you guys should know if we want to check the inlet thermistor in the same way. Where do we put our probes?
1, 2.
1, 2.
Yeah.
There you go.
So
Same
this is
deal.
not rocket science. What it is reading the schematic. And we keep emphasizing this because I see this over and over again. Guys are working on an electrical problem. They don't even look at the schematic. And you're not going to get anywhere if you don't do that. Now, let me put it this way. If you don't look at the schematic, you've got very little hope of actually troubleshooting the problem. You may guess and get lucky. You may have some experience, rule of thumb, whatever, but that's not troubleshooting. It's fair game on a service call, but that's not troubleshooting. And so if you're not reading the schematic, you've got very little hope of troubleshooting it correctly. If you do read the schematic, you've got a very high probability. You still may not be able to figure out what the problem is, but you're a lot closer than you ever would be by not reading the schematic. So it increases your accuracy and success at troubleshooting and fixing the correct problem.
Sorry, can I ask a question there? That's
Yep.
Absolutely. Yeah, go for it.
when you're checking the thermistors, do you have to disconnect one of the wires off the board? Can you check them with the wires on the board?
I like to disconnect because they're not showing me the circuitry on the board, so I don't know what kind of back reading I'm going to do.
Yeah,
They're calling
yeah,
this out as a P14 connector. It's probably all ganged together as one plastic, either edge connector or pin connector that goes on the board. Pull the whole thing off, doesn't matter what else is on
yeah,
there. And then I can just count off, pins 1 and 2 for the inlet thermistor and 3 and 6 for the outlet thermistor. Just count the pins.
Hmm.
yeah, yeah.
Yeah, because you would have your voltage divider circuit in there, and you want to make sure you're not reading across that.
Yeah. So that's the thing, because if it's still connected, you're going to be reading whatever else is going on the circuit board, or the voltage divider circuit, whatever, and it's all going to be in parallel with the outlet thermistor. And as far as the way your meter's going to read it. So
Yep.
you want to isolate it. Get rid of any confusion factor like that, and just know what you're doing when you're making a resistance measurement and what component you're actually wanting to measure. You're not interested in what's going on in the circuitry in the board. You want to check the outlet thermistor. So isolate it.
It's